All right, welcome to category B, where we are going to determine whether each given point is a solution to the system of linear inequalities. So let's take a look at number 3. We are given two inequalities and we are given a point. So what we have to do here is actually just plug in the point to make sure that it gives us the true statement for both, okay? So it's a solution if it's true for all the inequalities. I'm going to write that down. The point is a solution if it is true. Oh my gosh, I do not know how to spell true. Wow. True for all the inequalities. So if it's true for just one of them and it's a lie for the other, it is not a solution. You must be true for every single inequality in the problem, okay? So true for all the inequalities. If we're given two inequalities, we need it to be true for both of them. Not one true, one false, not false, false. You need it to be true, true. So true for every single one. Let's try to plug it in now. So for the first equation, we have 3x, and our x value is the -4, plus 2y, y value is -5, less than or equal to 10. Let's see if that is actually true or not. So 3 times -4, that's -12. And then 2 times -5, that's -10. So we have -12 minus 10, that's -22, is less than or equal to 10. A negative number is definitely less than a positive number. This is true. So far, we're doing good. Let's check to see if it's true for the other one as well. So we have -4x. Remember, x is -4, as shown over here. And then plus 2y. Our y is -5, as shown at the point. And then we want to see if it's greater than or equal to 15. So let's take a look. -4 times -4, that's 16. And then we have 2 times -5, that's -10. And this is greater than or equal to 15. Let's see if it is. 16 minus 10 is 6, is greater than or equal to 15. Oh my gosh. Well, that's not true. 6 is definitely not greater than or equal to 15. This is false. So since we did not get true for both of them, since it is false for the second one, this is not a solution. So I'm going to write not solution. And that's my final answer. It's not a solution because it was not true. We had a false, and one false is enough to cancel out the entire thing, so this is not a solution. Okay? So let's take a look at number 4. I want you guys to try it on your own, and then when we come back, we're going to see how you guys did. Okay, so hopefully now you're unpaused. Let's take a look and see how you did for number 4. So like earlier, we're going to plug it into both equations. Let's plug it into our first equation. Remember, your x is the 5, your y is the 2. So we have -2 times 2, our y value, plus our x value is greater than 5. Let's take a look to see if that ends up being true. So -2 times 2 is -4. So I got -4 plus 5 is greater than 5. Simplify that even more. This 1 is greater than 5. 1 is not greater than 5. This is a lie. So since our first equation already gave us a lie, do I even need to bother with the second equation or second inequality? Do I even need to care if it fits this one? No, I don't need to care anymore, because if it was false for our first inequality, this is not going to be a solution no matter what, because you need true, true. So any false that you get is going to cancel the whole thing. This is also not solution, not a solution. So the only way you can get a solution is if you get true, true. True for both inequalities. And in both of our examples here, we got at least one false. So it's not a solution. So if you get true, true, solution. If you get true, false, not a solution. You get false, false, definitely not a solution, okay? So that's it for this category. Please let me know if you have any questions, and I'll see you in the next video.